Yeah, good afternoon all. Am I audible? Hello?
Good afternoon, sir.
Yeah, good afternoon. Am I audible now?
Yes, sir.
Okay, okay. We'll start at 12:30. One more minute to go. Okay, we'll start now. This topic is welding. So, like we have 7 trades. So, welding is one of the trades. Um, People still joining. Okay. I think we have discussed 2 trades earlier in the month of April. Today I'll discuss about the welding, then I'll show you the recorded video, in the video which was recorded in our laboratory, workshop laboratory. Yeah. So let us first start with the introduction and definition of welding. So the welding is the process of joining similar metals by application of heat. Just a minute, I forgot to record. Just a record button. Record meeting. Recording. Start. People are joining. We had a pocket now. Okay. There are power cuts here in the college, so there may be some breaks here and there. Okay, so all of you please continue. Don't log out. Because as the power resumes, we can again continue your session. Okay. So welding introduction. So welding is the process of joining similar metals by the application of heat with or without application of pressure or filler material in such a way that The joints are equivalent in composition and characteristics of the metals joined. So mostly it is a method of joining similar metals. So nowadays even dissimilar metals are also being welded. Okay, like brass items and ferrous items are also being welded by some special techniques. So basically mostly welding is a process of joining similar metals. Okay, maybe two similar components which are manufactured separately and have to be jointed together, maybe for repair purpose also. So most of you might have come across welding in some videos, or maybe you might have seen in some welding shops lying beside the roads. So it is a method of joining two dissimilar metals. So and the joining of two dissimilar similar metals will not take place just like that. So you may have to apply heat, and you may have to apply pressure also, and sometimes you may have to apply filler material also. Okay, that you will understand while we are coming across the welding videos and slides here. Okay, so in the beginning welding was mainly used for repairing all kinds of worn or damaged parts. So predominantly it was for repairing of worn out and damaged parts in the earlier days. Okay, so now it is extensively used in manufacturing industry, construction industry, maintenance work, replacing, riveting and bolting. So riveting and bolting are the methods which are followed to join the sheet metals here. So even nowadays the riveting and bolting is also replaced by the welding method. Now here the welding is a type of permanent joining method. It's a permanent joining technique of two metals. So if you want to separate two welded metals, they have to be dismantled. They have to be permanently dismantled here. So it's a permanent joining technique for joining two components or two dissimilar metals here. Okay. So going to the next slide. So what are the various welding methods? Okay, just all of you have a glance of various welding methods. So you're not going to the top of each and every welding method here. So basically the welding methods are classified into various types. So one of them include arc welding methods. The other one is gas welding methods. Then we have resistance welding methods. Then we have arc welding machines which are used in arc welding methods here. Okay, so the classification is very huge here now. So we will just try to restrict ourselves. So coming to the classification of arc welding methods, under the arc welding methods we have about 7 types, like carbon arc welding, metal arc welding, tungsten inert gas welding, which is indicated by TIG welding, TIG welding. Okay. Then we have metal inert gas welding, MIG welding. Then we have submerged arc welding method, SAW welding. Then we have atomic hydrogen arc welding. Then we have plasma arc welding, PAW. Okay, there are like 7 categories under this arc welding methods. Okay, then we have under the gas welding. So basically here in the arc welding methods we depend on the electricity. Okay, so coming to the gas welding methods, we depend on gases here for generation of heat here out of combustion. Okay, so under the gas welding methods we have oxy-acetylene welding. Then we have air-acetylene welding. Then we have pressure gas welding. Then we have oxy-hydrogen welding. So oxy-acetylene is we use oxygen and we use acetylene gas separately stored in 2 cylinders. Okay. So similarly we have air-acetylene welding where we use common air as well as acetylene. Then we have pressure gas welding where we use the pressurized gases. Then we have oxygen and hydrogen welding method where we use oxygen gas and hydrogen gas for welding. So in gas welding, as the name itself indicates, we use gases here. Okay, we don't use electricity, but we use a torch created by the combustion of gases here. Okay, then the third one, which is a little bit modern, that is resistance welding method. So in resistance welding method, we apply the principle of resistance or resistive heating and generate heat and join the metals here. Okay, so in the resistance welding methods, we have spot welding method, we have seam welding method, we have projection welding method, and then we have flash butt welding methods. So coming to the arc welding machine methods, what are the machines which are used in arc welding methods? So we have arc welding machine at our workshop. Okay, so under the arc welding machines we have welding transformer AC, then welding generator DC. Now AC means alternating current, DC means direct current. Okay, then welding rectifier of DC. So basically rectifiers are used for conversion of alternating current into direct current. Then we have solid state inverters also. Okay, So basically we use a welding machine which consists of both AC and DC modes, which is available at our laboratory. Okay. So in our trade of welding, so we will be doing 3 experiments. So one is to weld 2 mild steel pieces as a lap joint here. I'll show you what lap joint is. Okay. So here basically we do welding on mild steel material. So here the workpieces are made up of mild steel. Okay. So the first experiment is to weld 2 mild steel pieces as a lap joint here. And the second experiment is to weld 2 mild steel pieces as a butt joint. So this lap joint or butt joint or T joint is a type of joint which is being generated by welding here. Okay. Then the third experiment includes to weld 2 mild steel pieces as a T joint here. So these 3 are included in the welding trade in our curriculum. Okay. So coming to the first experiment of lap joint, LAP joint, lap joint. So here the aim is to weld 2 mild steel pieces as a lap joint. The materials which are provided to you are of sizes 50 mm by 50 mm, 50 millimeters by 50 millimeters. Mild steel plates, 2 numbers, and mild steel electrodes are provided to you. So here the various tools which are required are like this. So secondary terminal, electrode holder, hand shield, chipping hammer, wire brush, hand gloves, and tongs. So these you can understand by seeing the video. Okay. So just remember the tools required: secondary terminal from the machine, then electrode holder. So there is an electrode holder which will hold the electrode. Then we have hand shield for protection. Then we have a chipping hammer for removal of unwanted material which gets deposited. Then we have wire brush. Then we have hand gloves and tongs. Okay, just a minute. I am getting a call. Just a minute. Hello. Okay, sorry. So where are we? Yeah, lap joint. Okay, so you'll be provided with the basic work pieces of 50 mm by 50 mm by approximately 5 mm thickness. So and the various tools which are shown here are will be provided like hand gloves, tongs, wire brush, etc. Then we have welding machine as the equipment, which is mainly required for the purpose of performing the welding. So without welding machine, you cannot do welding here. Okay. So coming to the next slide. This is what it appears in a lap joint. So you can just see here 2 metal pieces are overlapped one on top of the other. So you are creating a lap here. Since one is overlapping onto the other, it is called as a lap joint here. So you can see the percentage of overlap, which is approximately 25% compared to the thickness of 50 mm. So approximately 1/4 of this thickness is being overlapped here. So after overlapping, then you have to perform the welding at the intersecting edges of the 2 workpieces here. So you can just see here the curvy surfaces. These are the indications of the welding which is performed. So after welding, the joint will appear like this. So on top and at the bottom, you have to do the welding here to ensure the strength of this joint here, as the strength of the lap joint here. Okay. So once again, I just repeat, here overlapping one workpiece onto the other, not full overlap. It's approximately 1/4 to 1/3 of the width is being overlapped here. And after overlapping, you have to fix them one on top of the other without getting disturbed. Then you have to perform welding along the seam length at the edges of intersection. Okay. So this you can just see the weld length here from this edge to that edge. From end to end, the welding has to be performed. Now the welding has to be performed at the two sides. On top side you have to perform, and at the bottom side you have to perform to join these 2 metal pieces permanently. Okay. And the sequence of operation involve cleaning mild steel pieces. So the mild steel pieces which are provided to you are not ready for doing welding immediately. So they will be rusted and out of shape also. So one thing is to bring them to the required size and shape. Second thing is to remove the rusting and unwanted surface or unsettling objects which have to be removed here. So you have to clean the workpiece, you have to bring it to the required dimensions, and then only you have to perform the welding here. That is, you have to remove all the dirt and whatever the dirt which got accumulated and whatever the rust which has got accumulated on the workpiece here. So that is very important here. Okay, then placing as per the joint. So whichever type of joint you are required to do, according to that you have to position the workpieces one with respect to the other. Then you have to perform a tack welding. So tack welding also you will understand why it is done. It is like a spot welding to keep the two workpieces in position. Okay, then you have to do the actual welding throughout the length of intersection of these two workpieces at top and bottom. Then after welding, you have to do chipping operation. So why chipping is done also you will understand by seeing the video. So after welding, what happens is you will find the deposition of the weld metal here and there on the workpieces, which is unwanted. This is nothing but spilling of the molten metal during the welding process. So these unwanted weld mats have to be removed by the process of chipping operation. Physically you have to remove them. So for that purpose, you can use chipping devices and you can use the wire brush also. Okay. So these are the sequence of operations. One is cleaning mild steel pieces. Second thing is positioning them or placing them as per the joint. So in this case, it is the lap joint. Then you have to do tack welding to ensure them to be in position. This you will do two spot welding so that they are not disturbed here. Then you will do the actual welding, fourth step. Okay. Then the final step is chipping. So procedure is like this. First clean the given mild steel pieces with wire brush to remove the rust, grease and oil. So nothing should be present on the workpieces which are to be welded here. Otherwise you will not get a quality welding. Okay, the welding may not be of good quality here. So the type of depositions may include, first thing is rust because it is a mild steel workpiece. Second thing is grease, oily grease, then even oil also. So you have to ensure that these three are not present. Okay. Second thing, the two metal pieces are placed on the welding table separated by a gap of 2 mm. Okay. So there is a welding table available separately which is grounded electrically. Mostly it is a metallic table and the workpieces have to be kept one on top of the other as per the position, and a gap of 2 mm has to be ensured here. Then the third step is to start welding from one edge so that the entire joint of the two steel pieces is covered by the molten weld metal. This is actual welding. Then you have similarly weld the other side of the joint in the same way. So like we have, after overlapping, we have two intersections. One is on top, second on the bottom. So both sides it has to be welded to ensure the strength here. And strength is very important here. You are joining these two workpieces so that they are jointed to one another permanently. Okay. So the two layers of weldings will ensure the strength of the joint here. Then after cooling, using a chipping hammer, weld the bead chipping hammer, the bead clean by removing the slag or the bead here. The bead cleaning has to be done after the welding is done. So once welding is done, the workpiece has to be cooled by dipping in cold water. So after cooling it away, then you have to remove the unwanted weld metals and slag whichever has formed because of the oxidation here. Okay? So slag is an unwanted layer which gets formed on the weld mat or weld bead, which can be removed very easily by applying mild strokes by using a chipping hammer. Okay, so that is the procedure here. So the precautions are like this: welding should be cautious and continuous. Then you cannot break the welding here. Okay, you cannot do it discontinuously. You have to do it continuously. You have a continuous length of the weld bead here. Okay, so then you have to ensure that the welding table is earthed. That is very, very important here. So if the welding table is not earthed, the welding will not continue here. Okay, then edge preparation is made above 5 mm thickness or on one or both sides. Now edge preparation is very much important. That is cleaning of the intersectional joints. And then you have the final result, like an lap joint of 2 mild steel pieces is prepared by welding, which you write in the report after precautions. So this is about the procedure. So one procedure I have just shown here for understanding, that is lap joint. Similarly, you'll be having butt joint, then you'll be having the T joint also. Okay. So I have just shown you the lap joint, how it appears. Then this butt joint and T joint you can just see in the video. Now I will play you the recorded video, which was recorded live in your in our workshop. Okay, I'll just stop this sharing and I will share you the video. Okay. So just give me a moment. I will start the video and share it. Okay, so this is the video. Okay, I'll share you now. Okay. Present now. It's a window. Okay. Okay, so this is the recorded video. Introduction, preparation of the workpiece. I think you may not be listening the voice, so this is myself. This is a working shop, workshop for welding. I'll just give you the voiceover. So in this video, I'm just showing you the welding shop. So you can just see the tables here for holding the workpieces with bench vices. Then we have a welding table at the end. So he is Mr. Sheikh Wasim, who is the technician in the welding. So I'll just pause and explain you. So this voice is audible to me, but it will not be audible to you. So I'll just give you the voiceover. So here you can just see prepared weld joints. So one is T joint, the middle one is the butt joint, and the last one is the lap joint. So today we are going to do the lap joint here. So in lap joint we will overlap the workpieces one on top of the other. In the butt joint we will keep the workpieces side by side and do the welding. I think it got stuck. Okay, something went wrong, it got stuck. I'll replay it. Sorry for inconvenience. Let me replay it and share you again. One minute. Let's see. Yeah. Okay. Hope it opens. Things wrong. Many of them got stuck here. Okay. Sorry for inconvenience. Technical issues we'll be facing always. Somebody behind. God. It's not quitting and it got stuck. So problem with my laptop or what? End task. Okay, now it's working. Let us see. Share. Yeah. Good. Okay, so these are the three joints, three experiments. So you can see the one is T-shaped, that is one workpiece is perpendicular to the other. In the same position, it is welded. So that is T-shaping. So it is T joint. The butt joint, you can see the workpieces are placed side by side and they are welded together at the interface. So that is butt joint. It is called butting, keeping them side by side. Then we have lap joint, where one piece is overlapped onto the other, and then welding is done on top as well as at the bottom at the intersection. Okay, so that's what is explained in this video. So these are the basic condition of the workpieces which are provided to you. So they are cut into two pieces from a single piece. So all of you can just see the formation of rust and the burrs. And here you can see the safety devices include gloves and a safety shield. Then you have goggles, safety goggles, which you have to use during the welding for the protection of eyes as well as hand. Then you can just see here there's a wire brush for removal of unwanted surfaces and for the purpose of cleaning the workpiece. So this is the chipping hammer. Then you have the tongs for holding the workpiece, which will be in hot condition after welding. Then we have a file to remove the unwanted surface material, and that lengthy rod what you see is the coated electrode. Okay, it's called consumable coated electrode. Okay, and this is the bench vise in which you will be positioning the workpieces as per the required joint. So you can just see, you can just place the workpiece into those two jaws. So one is mobile jaw and another fixed jaw. And then the thing what you see there is the machine, welding machine, arc welding machine. You can see the terminals there, secondary terminals. So these two secondary terminals, one is connected to the electrode holder. So this is the electrode holder which is holding the electrode. The other one is connected to the welding table, which is grounded. And those two cables are connected to the welding machine. And he's Mr. Sheikh Wasim, our technician, will help you with the welding operations. So first thing, first step is to remove the unwanted burrs materials and cleaning of the workpieces. You can just see there after cutting, you can see the extended surfaces, sharp edges, which have to be first cleaned by using a file. That's what is explained by Mr. Sheikh Wasim. So it has to be first fixed in the vise. Now if you can just see the formation of the coating there, the rust is being formed. Rust has already formed and uneven surfaces. So now first thing is to prepare the workpiece, make them welding ready. Okay, so fix them in the vise. So this is the bench vise. You can just see here by anti-clockwise and clockwise movements of the lever, you can tighten it or loosen the jaws. So now the workpiece is fixed to remove the unwanted extended metallic projections by using a file. Okay, so by filing, you first have to remove the unwanted metallic extensions and projections. That's what is being shown here and explained by our technician also. So you have to do some filing. So it is the first step, preparation of the workpiece. So by filing, what I am doing is I am removing the projections of metal because of the cutting. So all the other edges also have to be filed here to remove the unwanted metallic surfaces as well as rust also. So all the edges like 1, 2, 3, 4, 5 edges we have. It's a simple process, not a very big process. So now I have ensured that all the edges are uniform. So like this, we may have to do some additional filing to completely remove the rusting. So on the other side also I am doing the same operation. You can just see the thickness, it is approximately 5 mm and the width is 50 mm. So all the edges have to be cleaned and prepared like this. So this is the live experiment which was recorded, and if you have an opportunity to come to college, you can do this experiment by yourselves under the guidance. So the same thing has to be done on the other workpiece also. So the experiment number 1 is lap joint. This is the welding table, which is metallic, and it has to be grounded. Otherwise, the arc initiation will not take place, welding will not start. So you won't get electrocuted here by grounding the table. So that's what you have to do first. Wear the safety goggle. Then on top of it, if you hold this face shield, it ensures more safety for face also. So here the arc initiation is done. Just repeat it once again. So you have to strike the electrode holder which is holding the electrode. So you have to touch the electrode with the table, which is grounded, oppositely charged in fact. So this is say positively charged, means that should be negatively charged. So this is connected to line, then the work table will be connected to ground. So now the workpieces are kept in position.
Sir?
Yeah.
Sir, someone want to join, sir, but you're not accepting.
I can't do 2 things at a time, no? That is my problem.
Yes, sir. Yes, sir.
Okay.
You forwarded to me, sir.
That's why I'm asking you to join the first 10 minutes, because I cannot switch over. Okay. Anyways, I will share the video. That person can just go through the video. The link I will share. Okay. Now here you can see one is kept on top of the other. The overlapping is done. About 10 to 15% overlapping is done. The arc is initiated like this, and you can see they're kept in place. So because our technician is experienced, so he is using bare hands, but you have to use the gloves for both hands. So this is tack welding. What you see here is tack welding. That is, 2 tacks are created at the 2 edges here. It is like spot welding to ensure that the workpieces are in position now. That is not the actual full welding. Now what we do is the full welding, running from end to end. So like I said, it's a continuous process. Welding is to be done continuously from one end to other end. So throughout the welding, what happens is this electrode gets consumed here. As such, it is called consumable electrode. So now I am admitting, but next class onwards, please join in the first 10 minutes. I won't admit, so that will disturb the class. Okay. So now you can see the welding is being done. And you should not see this welding process with naked eye. I have recorded. With naked eye, you should not see it. Only through goggles or safety shield, you can see the formation of the deposition of the weld met. So you can see the welding is run on one side, and weld bead is created here. Don't touch the workpiece here. Okay, I'm just showing you. So that is nothing but a slag which has deposited on the weld bead. So now what you have to do is you have to dip the joint in cold water. After cooling the workpiece, then you have to do chipping to remove the slag formation. So this is the safety the tongue with which you have to hold the workpiece. This is the chipping hammer. So keep it on the anvil and chip the unwanted slag coating. So that slag will come out very easily. So once you beat with the chipping hammer on the weld met or weld bead, you can just see very easily the layer is coming out. So that layer is the temporary layer, which is called slag here now. So you have to remove the slag by chipping here. So now you can see the actual welding. Okay, so there is a weld length. So like this, you have to do it on the other side also. So after chipping, you have to do brushing also. So other spots of weld metal depositions can be removed by wire brushing. So that is the workpiece ready. So the next experiment is butt joint experiment. So in butt joint, we'll place the workpieces side by side. So as per our requirement in construction of say bridges, we may have to generate what call the slab joints, or sometimes we may have to generate butt joints, or sometimes T joints also. Now let us see the butt joint operation. Now preparation of workpiece is same like what we have done in the lap joint. So let us just see the butt joint operation. So in butt joint, additionally, what you have to do with respect to lap joint is the edges have to be beveled. The edges which are intersecting or interacting have to be beveled. That is, the material is to be removed at the edges by an angle of 45 degrees. You can just see the inclination of the filing. It is to be done at an angle of 45 degrees with respect to one of the edges. That is, the vertical end has to be converted to a 45 degrees beveled edge. As such, accordingly, you have to position the file and do the filing. Now, the edge which was like vertical will become inclined now. I'll tell you why it is being beveled here. So, this process is called beveling operation. Both edges which are involved in welding have to be beveled here by 45 degrees. So, approximately 45 degrees. It will not be exactly 45 degrees. So, approximately 45 degrees. So, this process is called beveling operation. So, this is to be done on the two workpieces. On which side? The side where both of them intersect with each other. So, like this, you have to do it on the other workpiece also. By an angle of approximately how much? 45 degrees. So, with these beveled edges, when they are kept side by side, you will get a V notch here now. So, in that V notch, you can deposit the welding material. So, additional welding material will be deposited into that V notch, which will strengthen the joint here now. Now, you can just see the two workpieces are kept side by side, and you will find a V notch, and this weld metal gets deposited into that V notch, ensuring the strength of these two workpieces which are joined side by side. Because of the position, the strength will not be as much as in case of lap joint here now, because only edges are intersecting here. So, you can just see here the V type of valley. So, now here also the tag welding is done at the edges, then the remaining total length is covered by welding operation. So, this is what butt joint. Butting. Butting is keeping two objects side by side. They are butted together. So, because of this butting, the position is weaker in terms of strength. As such, you have to ensure the strength. So, you have to do the beveling operation and allow the extra space which can hold the welding material. So, additional welding metal can be held in this V notch. It should create a strong joint here. So that welding rod gets consumed here. It becomes molten and gets deposited into the workpieces. So the total V notch is filled by the welding material. So you can just hold the workpiece by using a tong. So this is called tong. So mind you, don't touch it by naked hand. Hold it by tong and dip it in the water, normal water, so that the workpieces can cool down. So you can just see spots there, the weld metal depositions which are to be removed by brushing and chipping. So after dipping in water, you have to do the chipping operation to remove the slag layer, which will break very easily. So now you can see the base weld metal, welding bead. So this is the butt joint. So again, you can do the wire brushing operation to remove the spots of weld metal. So that is the anvil on which we are doing this chipping and wire brushing operation. It is called anvil. So now your butt joint is ready. So basically, welding has a lot of applications. In structural applications like for construction of metallic bridges, trusses. Now let us quickly see the third experiment, that is T joint. So in T joint, one workpiece will be positioned perpendicular to the other workpiece at the middle half. Okay. So yesterday we are showing you how they have to be positioned. So exactly at the middle half, one is kept perpendicular to the other. Then on both sides you have to do the welding here. So first tag welding is done at the two edges. So arc has to be struck first like this. Then spot welding is done at the edges to position the two workpieces as per our requirement. On alternate sides, the spots are welded. Now the remaining welding has to be done on both sides. So it is giving you a T shape here now. So these operations you will do by yourself once if it is possible if you come to the workshop. So 2 or 3 students will form a team and they will do each experiment. Like for 2 students or 3 students, one workpiece will be given, one set of workpieces will be given. So one side is welded. So I'm just showing you with my finger, I'm not touching it, okay? So be careful. So here the care is very much important. You have to be very careful. Precautions you have to follow 100%. So safety is the top priority in the workshop. Now on the other side also you have to perform the welding operation. Mind you, that electrode is called consumable electrode. So now you can see the length of the electrode is become half because it melts and gets deposited on the workpieces. The sparking is created because of the opposite charges. That is, the welding rod is of one charge and the workpiece will be oppositely charged. That is, it is connected to ground and this welding rod is connected to line. If we are using AC mode, line current and neutral current or grounding current. If you are using DC, then the positive charge is connected to the electrode and the workpiece is connected to the negative electrode. So when you touch these two opposite charges, naturally because of huge energy transfer, the sparking gets initiated here. So the T-joint is ready for us to be cooled and to be chipped, and slag removal operations to be performed further. So here also chipping has to be done after cooling it. You can just see the powder, the breaking of the slag layer. So very mild force has to be applied, mild impact, not heavy impact. So it is to be done on the other side also. This is the T-joint. Likewise, we will be recording the other experiments also and we will show you the videos. So that is the T-joint. So welded long back. Okay. So these are the 3 experiments under the welding trade here. Okay. So I will just stop it here because I think it's time. Stop sharing and all of you. Now I request all of you please type in your roll numbers in the chat box and you can exit for the day for the lunch.